like to request you to please welcome our speakers onto the stage, Sri Lalita Tipanna and Shika N, cloud developers from HPE.
Hello everyone, good afternoon. Firstly, thank you GHCI for providing us this opportunity to present our uh, paper here and the experiment what we have performed using prompt engineering. So here we are here, myself Sri Lalita and Shika from HPE. We are here to present the work on using how we have used prompt engineering for our network log analysis. So this is the agenda for us today, which we both of us will be walking through. Firstly, to start with, introduction to GitHub Copilot. So imagine we have a coding assistant and which entirely knows the entire project, and it suggests us the code when we are typing in, and it also helps to solve the problems when easily within minutes. Now this is called as GitHub Copilot. It is an AI powered tool which is trained on billions of lines of code and different LLMs. So it uses the different editors like Visual Studio, VS Code, and JetBrains IDE, different kinds of editors. And not only this, but it also helps us to debug and find the errors in our code. And it also helps to write unit tests instantly. And it also helps to write the complex functionals using simple prompts. And also it sometimes helps us to understand the complex code within few lines, and also in a simple English which is understandable and readable to everyone. So now what is prompt engineering? So prompt engineering is an art of understanding how to use AI. So AI is, as we all know, that prompt engineering is the skill of crafting effective instructions to the AI, and how the best results have to be coming out from the AI. So it is, as we all know, that AI is becoming central of development. Prompt engineering is also becoming important as knowing the syntax to get the best results out of AI. So for example, if I give something a prompt like write a code for ABC website. So now this I can call it as a very bad prompt, because I'm not giving any important instructions or how the AI should or the prompt engineering should behave. So if I change something like create a website or create a navigation bar with a logo having four different menu bars, and also using Tailwind CSS, something like this. So now this is I can call a better prompt, and also a good prompt where prompt engineering is able to understand what it has to do exactly. So now why is prompt engineering important and why does it matter? So AI is in, we all know that AI is in the middle of we are in the middle of AI revolution, and prompt engineering is the bridge between human expertise and AI capabilities. So, for example, there are some few examples which I can explain. For example, explain garbage in and garbage out. So it is nothing but AI is very powerful, but what if we are giving vague prompts? The results also will be vague. So we end up in writing the code ourselves, and we also end up in fixing the code by ourselves. So that is a waste of our time. Secondly, the productivity gains. Reports or this recent exercises have shown that developers who have good prompting skills or better prompting skills can complete their task 2 to 3 times faster. And thirdly, the cost efficiency. So good prompts meaning fewer API calls, lower token usages, and it also lowers the cost. So this is how it makes us very important to use the prompt engineering. And not only this, we can also use, as mentioned in the slide, we can also use the prompts as and required, depending on the use cases, we can reuse them. And not only this, we can also get the structured output for an unstructured inputs. So moving forward.
All right. So let me walk you through some of the core prompt engineering techniques. First is zero shot. It's pretty straightforward, where you just provide a one-liner to the LLM, and then you just kind of want the LLM to just figure it out. So, but here the LLM has to be trained on a diverse set of data. And sometimes you might feel that it's giving too generic responses as well. Okay, next is few shot. This is where you provide one or two examples on any task you want to perform, and the model can refer to it and learn from it and then infer the logic behind it and finally give the response. So when you give multiple patterns in the prompt, right, it behaves like a minimal version of fine tuning. Next is role prompting. This is where you assign the LLM a particular persona, and then it uses relevant knowledge and then gives you a response. And then in schema-based, you control the response structure. And finally, in negative prompting, you tell the model what not to do. And this is pretty important in reducing hallucinations and also avoiding noisy output. Yeah, so you can combine some of these techniques together in order to provide the right context and instructions to the LLM, and also guide its reasoning process and also get the expected output. Right. So now coming to our use case where we've applied prompt engineering on network log analysis. Okay. So as you all know, log analysis is very crucial in root causing issues, and they also have to be triaged quickly. So some of the key challenges in log analysis are that you cannot manually go through all the logs, and it definitely takes up a lot of time, right? And moreover, storing all of the logs in a cloud store also consumes a lot of unwanted space. And another important thing is that you need to identify the key indicators which could lead to a failure. So all of this could be solved by using an LLM. And with the right prompt, all of this could also be automated. And so for this, we have experimented with role and schema-based prompting. Okay, and this is the experimental setup that we've used, which is basically a storage area network, wherein the switch is basically the key component which connects the server to the storage. And then we are pulling the logs from the switch using a REST API call and on a periodic basis, and then processing it on the edge, and finally pushing it to a cloud monitoring platform, which is OpsRamp in our case. Yeah, I think now Srilata will explain role-based prompting in detail.
Yeah. Ashika explained us different types of prompt engineering techniques. We have chosen two prompt engineering techniques, that is role-based prompt engineering technique and schema-based prompt engineering technique for our log analysis for the network logs. So so role-based prompt engineering technique is nothing but an guiding or teaching AI who to be. So we basically give a persona or the role to the prompt engineering so that it can assign that specific role and think in that way and respond to us. So we also have, for example, if I say you are a Python developer to the AI adjusts its vocabulary, depth, and try to adjust itself for that expertise level and tries to answer and think and respond to our query. So similarly, in the role-based prompt engineering technique, we have different kinds of roles which we can assign depending on our different use cases which we have. For example, as listed out here, we have professional roles, educational roles, teaching roles, and also functional roles. So depending on our use cases, we can basically select and choose on different kind of roles which we can assign. And sometimes we can also have combine some of the roles while using the prompts depending on the use case. So for example, if I say you are a senior developer and you are trying to review the code for an ABC startup company, so I'll ask it to explain or focus on security and scalability features. So now that will exactly do that part for me. So now here, this slide shows the basic prompt which we have used for the network log analysis specialized, which we have mentioned like error dump here, which it is also trying to understand and come out with the best results. So the GitHub Copilot came up with the different reasoning steps as mentioned here, like data understanding and preparation, duplicate removal, and log analysis and categorization, and severity based on the classification, and visualization and reporting as well. So depending on these classifications, the LLM processed and it came up with the different results for us, which we expertised by making the prompt more and more better, which we expected, like when until we wanted the results to be expected format. Okay, so now as we know that in role-based prompt engineering, the prompt understands, gets its expertise level to understand and come out with the best results for us in a dashboard format. So this is the best way of giving the results in the role-based, which we can use for the presentation purposes. So here, as you can see, we have analyzed around 10 log files, network log files, and analyzed the logs from the prompt engineering, which is role-based. So here you can see that around 20,024 event logs had been generated, and among which five were critical events. So we also asked for the log severity distribution, which is also in the graphical format. And in the right side, you can also see that top 5 critical events, we wanted it to be listed out separately in the column, which has come out in a very proper way. So this kind of visualization is presented in the role-based prompt engineering technique. So this is very useful for us, not only for network logs, for different kind of logs also we can experiment it.
All right, now coming to schema-based prompting. Yeah, so as mentioned earlier, the schema-based prompt output is very predictable, and we basically force the LLM to perform all the subtasks which is mentioned in the predefined schema or the template. So schema-based supports multiple formats, that's JSON, YAML, CSV, etc. And one example of a custom format is where the LLM's goal is to plan and not to jump into the code implementation. So you would expect the LLM to return a markdown or a document file, right? And one advantage here is that the output of the schema prompt can be validated and also be integrated into any automation pipeline. So this makes it pretty useful. Right. So yeah, so this is one of the examples of the schema prompt that we have used in our analysis. And you can see that in the first line, which says analyze the provided logs. That is basically the task that you're providing. And after that, we're also providing the log file as the context, and then the reference manual as additional context. And since our log was unstructured, we are providing the input log schema. And if you see the next line, we are instructing the LLM. Sorry for that. So yeah, so if you see in the next line, we are providing the instruction to the LLM that we need to output strictly a JSON file or object only. And then we have carefully curated the output schema to perform multiple operations. First is filtering duplicates, and then next is detecting anomalies based on the categories that we have defined. And also, it is important to identify the source of the error using the port details. And we were also interested in understanding some of the events which are related to that anomaly. So we have included that as well in the prompt. Right. So when the prompt runs in agent mode in Copilot, basically what happens is that there's an inbuilt function which fetches and indexes the log files or the additional context that we have provided, and uses it in its reasoning process. So this is the technical report which was generated by the Copilot. And as you can see, it has filled all the fields according to the schema. And so basically, LLM acts as an API, you can say. So we have experimented this on 10 different log files. So, and one thing to note here is that the LLM has a token limit. So in our case, 500 events were there in the log file, and it was able to read it. But one good practice is that it's better to process the logs in batches to get effective results. Right. So in conclusion, we feel that based on our evaluation, we feel that schema-based prompts business impact is very good. And that is because we were able to identify certain patterns which could lead to certain errors. And that helped us in solving customer issues. And nextly, error prevention, right? So as I mentioned earlier, schema-based prompts output can be validated. So there is no false positives, and it can be reduced as well. And then time to insights for schema-based is slightly higher. That is mainly because, time to insights is slightly higher. That is mainly because for complex schemas, right, LLM takes more time to process, and and give results. So that is why it is a good practice to break down the prompts into multiple prompts and then pass output of one prompt as an input to another. And this technique is basically called prompt chaining. And finally, the visualization quality of role-based prompt is really good. That is because it outputs a visually appealing dashboard, and it can be used in presentations. Whereas in schema-based prompt, you get the technical reports, and it's mainly used in production workflows. And so as a result, we suggest that using role and schema-based prompts as a hybrid approach would yield better results. And as the role-based schema provides the domain expertise, and the schema-based provides the response structure that you need.
So as Shika explained about schema and role-based prompt engineering techniques, so while doing the experiment of this with the network log files, what we understood is like there is always unpredictable output without prompt engineering, and we also do not get the structured output from the prompt engineering results. So in case when we are using different kinds of prompt engineering and try to get the results are in a very structured format like JSON, CSV, or any structured format which we require for. And also, these are some of the few best practices which we came across and we thought of listing over here. Firstly, we should always provide a high-level context with the detailed instructions, and it is also best to provide as much as examples we provide for the prompt so that it can understand better and give the results accordingly. And it is also good to reiterate the prompts so that it understands the prompt, whether it is role-based or schema-based or any other technique. Reiteration is very important. And also, if we have any referring files which the prompt has to refer for, we need to keep a tab open in the IDE so that the prompt can refer to the files and then generate the results. And lastly, we should always try to assign a role for that particular persona so that it can act accordingly and the AI can adjust its vocabulary and give the detailed information according to that. So this will help us in any kind of log analysis which we are doing using prompt engineering. So finally, these are the references which we have used, and we came across this. Most of the things are useful, and when you have time, you can go through that, and it will also be useful for you people. So thank you. But before closing, we'll try to call upon our co-authors Ranganath Prabhu and Narasimha Sastry on the stage, and we are open for any questions.
Hello. Yeah. So thanks for the interesting session. So you said you have used models. So maybe it was outside the topic, but was it a homegrown LLM or it was a fine-tuned one?
I would like Shika to answer it.
Yeah, so basically in Copilot, it provides an option for multiple models. So you can select any of those. So there is like options like Claude Sonnet, there is Gemini, whichever you want, you can use that. And then we have used that LLM and we have given that schema prompt for it to respond, fill it, and then it has done the log analysis.
So the usual LLMs that are available in Copilot, you use them to give the schema prompts.
Right, right. Okay. This year we have not created any model of our own because like currently everybody is working on that.
Yeah, I understand. Thank you.
No, we are expanding on the capabilities of the schema-based prompt. So based on the logs, see, you get unstructured logs. So you have to actually define the schema. So what are the feature sets which are important to you? You can select it by defining the schema. So we are actually defining the schema, what is important to us, what is our feature set, and then based on that, we are actually doing the analysis.
Hello, sir. I just have one small question that I saw in the role-based prompt. You used a dashboard to visualize the responses and the prompt. What was the tool that was used to visualize and create that dashboard?
Yeah, so basically for role-based prompt, we have generated the code. So that code internally, like using basic HTML, CSS, it was generated, and using that we were able to visualize.
Okay, thank you.
One question. So apart from network logging, have you used this for anything else as well? I mean, maybe more.
Yeah, we have used this for log analysis, but the process remains the same, right? You can use the same schema and then, I mean, maybe tweak it a little bit and use it for any other use case as well. So it's pretty generic.
Okay. Okay, thank you.
Adding to it, we can also used it for many customer log analysis and also for brokerage switch log analysis. So which we have come up with the different schema-based prompting.
We try to make it generic log analysis. It is not only specific to say fiber channel network switch or a network switch, actually iSCSI like that. But usually we try to apply the techniques role based and schema based across all the types of network related
But
switches.
other than network logs, have we also used for user journey or something like that?
We have storage logs,
Okay.
server logs.
So have we tried to get the user
Yes.
journey out of these logs?
Yes.
Yes.
Right. I think if there are any more questions, we can take them offline. Please give them a big round of applause. We'd like to thank
Thank
Sri
you.
Lalita
Thank you.
and Shika for that presentation on prompt engineering for network log analysis. We'd like to present both of you with a small token of our appreciation. Thank you.